Next, we have Solving the Problems of Pancreatitis, presented by Dr. Abraham Orabi Sahib. Dr. Orabi Sahib is a research assistant in Hussain Laboratory at the University of Pittsburgh.
Assalamu alaikum wa rahmatullah. Thank you. In the spirit of honesty, I should just admit I'm actually not a doctor as of yet, but thank you for the for the promotion. I have my bachelor's degree from the University of New Haven. I've been working with Dr. Hussain for a number of years, and it's been a very fruitful endeavor for, I'd like to think, both of us. I'm going to tell a story today, and it's a pretty big story just by the title, but I'm going to try and focus just on the big picture. Speaking of pictures, this is Pittsburgh, downtown Pittsburgh, which is obviously a very beautiful place, and this is where our facilities are located at the University of Pittsburgh, and we do a lot of exciting work there. So solving the problem of pancreatitis. Now again, this is sort of a big picture subject, and just to prove to you how serious I was in preparing for this talk about getting behind the idea of a big picture, I took a trip to Hawaii, and I just isolated myself, and I just thought about getting the big picture for this story. And so I hope I can convey this in just a few short minutes and tell you the importance of what we're doing in the lab and how it might be relevant to some clinical situations for people, the unfortunate people who suffer from this painful disease. So let's start with what is the pancreas? Well, it's actually a gland. It's an organ, and it's more specifically a gland. And what we mean by that, if we take a closer look at the organ, it looks a little something like this, and it's located in the upper abdomen. And we call it a gland because it secretes things and products. And it's a unique gland because it actually has functions of two subcategories of glands, which is an endocrine component, which we call pancreatic islets, and they help regulate your blood sugar. That's namely what they do. The types of cells that we focus on are part of what they call the exocrine pancreas, and these are called pancreatic acinar cells. And acinar cells secrete enzymes which help you digest your food after a meal. And so the focus of the lab is on the acinar cell component of the pancreas, which actually makes up the majority of the pancreas. So what is pancreatitis? This is the disease we study. And if the top left image is what a healthy pancreas looks like, the image on the top right is something of what pancreatitis looks like. And as you can tell from the image, in a few short words, pancreatitis is simply the inflammation of the pancreas. And what does that mean? Well, there's many things that cause pancreatitis. And there's many things that we're not sure. There's many times that a patient will present with pancreatitis and we don't know why. But I've listed here a few of the known causes of pancreatitis, namely alcohol abuse, the presence of gallstones, certain medications can cause pancreatitis, and also some kinds of trauma can cause pancreatitis, which I'll talk a little bit about in the next slide. But essentially the pathway that we're looking at is a very specific one. And again, thinking about the big picture, I've sort of narrowed it down to the 3 or 4 main processes that take place during the initial injury that occurs to the pancreas during a pancreatitis event. And it begins with the elevation of calcium within the cell. And most of us think of calcium as something that we get from, say, drinking a lot of milk or something that's good for our bones. But actually, calcium is a very important ion which is present in many of our cells, and particularly in the acinar cell, the pancreatic acinar cell. And it helps regulate a lot of processes within the cell. Now, what happens during pancreatitis is that the levels of calcium within the cell are elevated past the normal point. And what happens then is a little bit of a mystery, and that's sort of what we're trying to figure out. But we know that somewhere down the line there's the activation of these enzymes which normally digest your food, but instead they start to digest the organ. And that's where the problems start to take place. And after that occurs, that's when we get our disease, pancreatitis, and i.e. inflammation. And so that, again, is a very basic pathway that we're working with. But I'd like to just talk about another cause of pancreatitis that I'm just going to mention a little later as well when I show some of our data from the lab. There's also a clinical procedure that takes place in some patients called an ERCP, which the long name for that is given below, which stands for endoscopic retrograde cholangiopancreatography. And that's done in order to visualize the ducts of the pancreas, not the pancreas, but rather the liver and the gallbladder and those organs when there's an incidence of blockage or some other problem that's being investigated in the clinical setting. And what happens is the patient has an endoscope, which is basically a camera inserted through the mouth and down the esophagus where your food goes, into the stomach, and then into the first part of your intestine. And then there's what they call a radiocontrast, which is secreted or ejected from this device into the ducts of the liver and pancreas. And what happens is that in some patients, roughly 5% of patients develop pancreatitis following this procedure. And what our lab is trying to investigate now is why is that and what's the mechanism behind that? And I'll show some data pertaining to that topic in a little while. So a little bit about how we treat pancreatitis currently. In short, we don't do a very good job of it. The basic treatment is to give hydration through intravenous fluid. But our lab and many others are trying to look for a better way to treat this painful disease. And so when I was pondering, again, the big picture, I was sort of searching for insight from the Holy Quran as well as Hadith and trying to understand maybe ways in which we formulate our ideas about how to treat this disease, as well as other diseases. So the verse that I had found, which was sort of triggered a spark in my mind about how we think about disease and treating it, was from Surat Al-Isra, which translates to the night journey, and it's chapter 17. And verse 82 reads, وَنُنَّنزِلُ مِنَ الْقُرْآنِ مَا هُوَ شِفَاءٌ وَرَحْمَةٌ لِلْمُؤْمِنِينَ وَلَا يَزِدُ الظَّالِمِينَ إِلَّا خَسَرًا. And the English translation of that is, and when we send down of the Holy Quran that which is healing and mercy for the believers, but it does not increase the wrongdoers except in loss. And I think there's many ways of interpreting this surah. One way is to think that the Quran itself has a healing power for us, which it does, but also that the Quran contains information within it that may allow us to heal people or ourselves by using the knowledge and science that we've heard so much about today. Another hadith, or a hadith rather, that speaks sort of more specifically to this point can be found in Al-Bukhari, chapter 7, verse 582, which reads, "For every disease there is a medicine, and if that medicine is applied to the disease, he will recover by Allah's leave." And he, sallallahu alaihi wasallam, said, "Allah has not sent down any disease, but he has also sent down the cure. The one who knows it, and the one who does not know it, does not know it." And I think that's a very poignant hadith, and it was something that really struck a chord with me in the fact that I spend so much of my time investigating a disease, and our lab, as well as others, are trying to find cures. So now the question arises, how do we improve treatments for pancreatitis? And that's really what we're actively trying to do. So what we've done is we've tried to focus on one very specific aspect of this pathway, and that is what is the link between calcium and everything that happens after calcium. So namely, the question mark in the cartoon, what is the target of calcium? And this is something I spoke about last year in a little more detail with regards to calcium, but there's many targets of calcium in the cell, not just the acinar cell, but other cells. And the one that we've picked up on and really invested most of our time studying is a phosphatase, or an enzyme called calcineurin. And the name lends itself nicely to being a target of calcium because it derives from the word. But we believe that calcineurin is a critical link between calcium and the initial phases of pancreatitis. And thinking back to the model or the form of injury of pancreatitis that we often see in the clinic of ERCP-induced pancreatitis, we've decided to investigate the question of, does blocking calcineurin protect mice from this form of pancreatitis? Unfortunately, we haven't been able to perform these studies in humans, and that's the reason we chose to work with mouse models. So we have a mouse model of ERCP pancreatitis in which we perform a very similar procedure, and we treat the animals with inhibitors of calcineurin. And so I'm just going to show this piece of data, which on the top left, the control is a normal pancreas without any treatment from a mouse that didn't receive any procedure. The middle picture is from a mouse which received a similar procedure to that of an ERCP, in which it received some of the radio contrast, or that agent which we believe may be harmful. And on the far right, this is the pancreas from a mouse, again viewed under a microscope, that received an ERCP similar procedure with a calcineurin inhibitor. And in basic terms, what we see here is that the last picture on the far right looks a lot more like the first picture than the middle one, suggesting that if you give animals calcineurin inhibitor during or before they get the form of injury, that it's protective against the disease. And that's what the graph at the bottom shows. It's a quantification of the injury. And so this is important for many reasons, which I'll get into a little more in the next slide, but namely we believe that this may be important for patients. And so in summary, I've discussed that pancreatitis is a painful disease, and that solving the problems will rely on discovering targeted therapies as prophesied in the Holy Quran and Hadiths. The intracellular calcium elevations are an early and critical step. Calcineurin is a target of calcium. That blocking calcineurin protects against ERCP pancreatitis in mice, and that we believe that this can be translated to the clinical setting in order to provide patients who receive an ERCP a therapeutic approach to preventing them from undergoing this painful disease. And so with that, I'll end and just acknowledge the members of our lab, which do all the work, and I'll leave it at that. And Jazakallah for the opportunity, and thank you very much for your attention.